A motorized wheelchair is required for clients with spinal cord injury who are unable to propel with the upper extremities, require power sitting function to accomplish effective pressure relief and positioning, or have a comorbidity such as shoulder pain or limited endurance that reduce the ability to propel a manual wheelchair. They are also useful for those who are unable to propel a manual wheelchair or who may need to use a wheelchair for distance or over terrain, which would be fatiguing in a manual wheelchair. Wheelchair users are a group of people that live like a normal human being in this world. They have work, they have fun, and most importantly, they have life. There shouldn't be spaces like offensive assumptions where one think that they are out of the spaces. Wheelchair users belong to anywhere just as much as you and I do. For introduction, the problem statements are: existing electric wheelchairs are not affordable for the B40 and M40 individuals with movement disabilities. Individuals that require assistance could not operate the wheelchair by themselves. Caretaker not given additional option to move the wheelchair. And lastly, hospital wheelchairs are not given regular maintenance. The objectives are to design an economic electric wheelchair package for B40 and M40, to integrate safety elements for the safety of user and surroundings, to be physically controllable by a joystick controller, to design with ergonomic considerations, and lastly, to test and validate the design of the motorized wheelchair attachment.
Pada pendapat saya, design pertama yang menggunakan analog ni lebih mesra pengguna lah berbanding design yang kedua yang menggunakan button untuk mengawal kursi roda ni. Berdasarkan pengalaman saya, kadang saya akan berasa kurang selesa untuk mengawal kursi roda ni kerana kedudukan controller tu tidak strategik. At least controller tu boleh diselaraskan agar tangan saya selesa untuk mengawal. Okay. Selain daripada itu, harga kursi roda ni agak terlalu mahal sehingga bercecah sampai RM3,000.
The result on interview session with Encik Abdul Latif is translated into design requirement to develop motorized wheelchair attachment. Based on the table, the first criteria is design and functional. First design is use joystick and second design is use button. Next, the first design is strongly agree for friendly user and second design is intermediate. Same goes to criteria easy to control. After that, the range price for both design is same, which is below RM2,500.
I will be sharing about our product parts from an in-depth view. The mechanics of our product is an attachment to most available hospital wheelchairs. Therefore, we have designed a chain case that can be attached to any ABS plastic hospital wheelchair rims in the market. The design of our product aids in manufacturing costs as we have designed the motor plate to be printed against the grain to increase its lateral strength. Each side consists of motor, sprocket cover, chain case and motor plate. As for the control side, consists of battery, Arduino board, Bluetooth module and a motor driver. Once the motorized wheelchair is fully installed, the motors can be easily removed by sliding it out from the motor plate. The integration of Bluetooth connectivity to our product open possibilities to control the wheelchair using various devices our owner owns, such as PS4 controller app on any smartphone, and of course physical joystick for the patient that can be installed on the side of the patient's dominant arm.
The first analysis is the material selection analysis. These are all the steps needed to go through to select the materials of the components. Through this analysis, low alloy steel was selected since it has good corrosion resistance, high strength and adequate fracture toughness. With these properties, it can ensure that low alloy steel can be the perfect material for the fabrication of the parts and will not fail out in the field.
Next is the ergonomic analysis, which is known as ruler analysis. This analysis is done with 3 percentile, which is 5, 55 and 95. The percentile is subjected to the wrist and arm, trunk and posture of the wheelchair user. The user's wrist is located at the seat frame of the wheelchair to rest their hand and control the joystick. From the ruler table score, the mannequin indicates that trunk and posture is negligible risk as it scored 1, while wrist and arm scored 2, which considered as low risk for both male and female. From this analysis, we suggest an improvement in joystick length placement to reduce users' fatigue level.
As for the structural integrity of our product, finite element analysis has been done to show the weak points of the part. The static analysis shows adequate structural integrity for our application. The four major components, as you see, are part of the drivetrain, which is integral to be simulated to help with the design process.
The last analysis is cost analysis, which allows us to analyze the product cost usage for the product. The main material that we plan to use for actual product is low alloy steel. However, due to prototype rescaling and limitations faced during the fabrication process, we have decided to use ABS material for every component of the prototype. The material is provided by our supervisor, Madam Rosie. These are the receipts for the item that we have bought. The items were bought at electrical hardware shops in Malacca. For fixed and variable costs, assuming 60 units are produced in 1 month, fixed cost for the product is 51,918 ringgit. Variable cost is 10,000 ringgit, while the total cost production per unit for this product is about 1,031 ringgit and 97 cents. From this result, 136 units of the product must be sold to break even. By using the break-even table, percentage of contribution margin can be calculated. Hence, the percentage of contribution margin that we will achieve is 30%.
So now let's move to the manufacturing process. There are basically 3 manufacturing processes involved in the fabrication of the prototype: cutting, joining, and also additive manufacturing. As for the cutting process, the laser cutting process is used. Laser cutting process is a thermal process in which a high-power laser is focused through optics in a localized region to melt the material. Laser cutting machine is operated by CNC, thus offering a clean cut with high precision and low tolerance. In short, it is a mechanized thermal non-contact tool that can cut most materials with high degree of accuracy and precision. Next, as for the joining process, we have used MIG welding. MIG is a thermal process where consumable MIG wire electrodes are used to heat 2 parts of workpiece, forcing them to melt and attach together. MIG is considered the most durable of all arc welding procedures. MIG welding process enables most ferrous and non-ferrous alloy to be welded in a wide variety of thickness and welding positions. Lastly, 3D printing, also known as additive manufacturing process, is used. 3D printing is a method of creating a 3-dimensional object layer by layer using a computer-created design. Next, I will talk about process justification. So there are a total of 5 parts which we fabricated. We used the laser cutting process to cut the low alloy steel for the production of chain case, motor plate, joystick plate, and the control unit box. According to CES, low alloy steel has strong corrosion resistance. Laser cutting does not have too much effect on the low alloy steel since it has strong resistance to corrosion, so it makes laser cutting an ideal process. After cutting, we join the parts by using the MIG welding process. The MIG welding is the most suitable process to combine the part low alloy steel. MIG welding is a more simple process because it can be applied in many situations and it can be used to weld thin and thick layers of metals up to 12 mm thickness. Thermal expansion distortion is also reduced by designing symmetry in the weld lines and balancing the weld across the structure's neutral axis. These parts were fabricated effectively and successfully. Lastly, 3D printing process was used to fabricate the joystick housing. PLA filament was the raw material used. We decided to use this process to make the joystick housing lightweight. 3D printing also creates less material wastage, thus it was the most cost-effective process used.
Due to pandemic issue, it has limited the process fabrication for our product. Therefore, we have decided to fabricate a prototype motorized wheelchair attachment with scale 10 times smaller to show the functionality of how our actual product will look like. Plus, with the scale size, it will be hard to prove and show the movement of wheelchair by using only joystick. Therefore, we created an improvement and additional features, which is the motorized wheelchair attachment can be controlled by using Bluetooth on the smartphone. The prototype uses Arduino Uno, motor driver L298N, joystick, Bluetooth controller G35 and are powered by power bank as replacement for the battery. As seen in the video, the prototype is controlled using the Bluetooth system with 1 meter distance from the prototype. From this experiment, we can see that the wheelchair is able to move and turn effectively along the line set with the program. This shows the successful of the system on the prototype to be proceeded to the actual product.
In the sustainability aspect on motorized wheelchair attachment, We are going to discuss on three main categories, which are steel material for housing casing of the DC motor, PLA material for the chain case, and lastly, low alloy steel material for the main component such as control unit box and joystick plate. The steel material is chosen for the housing casing of the DC motor, which function as to cover the DC motor, whereas the electrical power through direct current is converted into mechanical rotation, which also to allow movement for the wheelchair. The good impact of this material is the easiest material to reprocess, as they can be separated from the waste stream. Also, any grade of steel can be recycled to top quality new metal, with no downgrading from prime to lower quality material, as steel is recycled repeatedly. The PLA material or polylactic acid is used for the chain case due to its lightweight material, as the function of the chain case is to protect the user from getting tangled in the chain. PLA is somewhat more sustainable than plastic from fossil fuels due to its production from renewable raw materials and the possibility of biodegradation. Thus, it's easy to work with PLA as it requires less energy to transform and it does not release toxic fumes when oxygenated. Lastly, low alloy steel is chosen for the function of the main component, which are control unit box and joystick plate. The good impact of using this material is it can improve certain characteristics and microstructure is more stable at elevated temperature. Other than that, low alloy steel have more advantage than closer material like carbon steel. Low alloy steel are better in terms of strength, hardness, toughness, wear, and corrosion resistance and hardenability. As a conclusion, it can be shown that a new modular device that can be used for converting a mechanical wheelchair to an electrical one in the term of the average cost of an actual electric wheelchair. The idea that has been outlined and expanded in this presentation will provide a cost-effective solution for electric wheelchair without exposing common wheelchair that is mainly provided in hospital and other public places. Therefore, motorized wheelchair attachment will be able to contribute to the society in terms of cost saving, as well as introduction of green technology, as waste of wheelchair will not be concerned for the implementation of this product.